Hello, everyone. How are you doing? Today, we're going to talk about determinants, okay, which is, in essence, a number that we can associate to a matrix in mathematics, okay? Um, we could basically, we could just do, I could just do a video explaining what is a matrix and when matrices are used in general math and engineering and all general applications that we can see in our day by day. But I decided to record a video regarding determinants first because it's more practical to teach, and also the exercises are more direct than to analyzing in the matrix context. Okay? I'm going to talk today about determinants in matrices 2 by 2 and 3 by 3. In the next class, probably in the next video, I'm going to show you on how we calculate determinants of matrix n by m, where n equals a number higher than 3. So from 4 above. 4 by 4, 5 by 5, etc. Okay? So let's start sharing the screen where I have an example of a matrix 2 by 2. So here we have matrix, and bear with me, some numbers are in Portuguese, okay? It's some names are in Portuguese. It's just a few names, so I didn't bother to translate into English, but here we have a matrix 2 by 2 and a matrix 3 by 3. A matrix 2 by 2 is a matrix where we have 2 rows and 2 columns. So row 1 here is 1 and 3, row 2, 5 and 7, column 1, 1, 5, and column 2, 3, 7. Matrix 3 by 3, we have 3 rows and 3 columns, okay? The idea of calculating a determinant of a matrix, first of all, you need to remember that only square matrices have determinants. In other words, for a matrix to have a determinant, it has to have the same numbers of columns and lines, or columns and rows, I'm sorry. So you need to have 2 columns and 2 rows, 3 columns and 3 rows, 4 columns and 4 rows. We would never have a determinant of a matrix, which is, for example, 3 columns and 2 rows, vice versa, okay? So to calculate the determinant of a matrix 2 by 2, you need to first calculate the product of the numbers in the main diagonal, or this diagonal here, which is the descending line going left to right. So what is the product? 1 and 7. So 1 times 7. And then you put a plus sign in front of it. Since it's the first number after the equality sign, I don't need to put it, right? As an example, when you say 1 plus 2, you do not say plus 1 plus 2. Because the first number, if you didn't say anything, it is implied that it's a plus. So 1 times 7, and then in the secondary diagonal, this one here, which is the ascending line going left to right, or the descending line going right to left, this diagonal here, you calculate its product, which is 3 times 5 equals 15, and then you put a minus sign in front of it. So 3 times 5, and you put a minus in front of it. Then you calculate the equation. 1, the count. 1 times 7 minus 3 times 5 equals 1 times 7, 7. 3 times 5, 15. With a minus in front of it, minus 15. Then we reach 7 minus 15, minus 8. To calculate a determinant of a matrix 3 by 3, we have a tool, okay, in which we repeat the matrix exact like here, okay? When we put vertical bars, we are representing the determinant, and when you put parenthesis signs like this here and this here, you are representing the matrix. So in order to calculate the determinant of a matrix 3 by 3, you repeat the matrix, and then on the side, you repeat the first and the second columns. So as you can see here, 1 to 6, I repeat it here, 1 to 6. 4, 1, 1, I repeat it here as well, 4, 1, 1. And then I'm going to calculate the products of the diagonals, this descending diagonals from left to right, and I'm going to put a plus sign in front of it. Or in other words, to maintain the sign of the product. For example, 1 times 1 times minus 2 equals minus 2. If I put a plus sign in front of it, I am maintaining the sign of the count. So it's going to be minus 2. 4 times 0 times 6, 0. If I put a plus sign in front of it, plus 0. Minus 3 times minus 2, minus 6. Times 1, minus 6. If I put a plus sign in front of it, I maintain the sign of the result. So it's going to be minus 6. Now I'm going to look at the ascending lines going left to right. So all of the products, I'm going to put a minus sign in front of it. In other words, I'm going to invert the sign. So we have here minus 3 times 1 times 6 minus 18. If I invert the sign, in other words, putting a minus sign in front of it, minus 18 becomes plus 18. So I put here plus 18. 1 times 0 times 1 equals 0. If I put a minus sign in front of it, it becomes minus 0. 4 times 2 times minus 2 equals minus 16. If I put a minus sign in front of it, I'm going to change its result sign. So instead of minus 16, I'm going to have plus 16. Then I'm going to add up all of these results here. So minus 18, plus 18, minus 0, 18, plus 16, 34, minus 2, 32, plus 0, 32, minus 6, 26.